Okay, section 4.1 is about probability distributions. Okay, a couple definitions. Let's start off with some definitions. Okay, the first one is random variable. Okay, random variable. A random variable x, I guess is what I should say, x. Random variable x, this represents a numerical value associated with each outcome. Of a probability experiment. Okay, so a random variable x. This random variable x represents a numerical value associated with each outcome of a probability experiment. Okay? Two types of random variables. Okay? Two types of random variables. The first is discrete. A discrete variable has finite or countable is that what I want to say? Sorry, has a finite or countable number of possible outcomes. Another way to think of it is all the outcomes could be listed. We can make a list of all the outcomes. Okay? So a discrete variable has a finite or countable number of possible outcomes. Okay? Excuse me. The other type of random variable is a continuous variable. C-O-N-T-I-N-U-O-U-S. So if this one has a finite or countable number, continuous will have what? An uncountable number of outcomes. Or possible outcomes. Just something to think about, that a continuous variables will be represented as an interval on the number line. And here's what I mean by that. If we're talking about a discrete variable, discrete values, for example, like that, I'll have 1, 2, maybe 4, and 5. But it looks like dots, right? Maybe even 3. Maybe all of them, right? 1, 2, 3, 4, and 5, but they are individual dots on a number line. On a number line, if I'm talking about a continuous variable, it'll be like this. Okay? In some of these examples that are in your textbook, you can look at and see what I'm talking about. But it kind of gives a little hint word to remember if you're trying to decide between discrete or continuous. Discrete can be counted. Continuous has to be measured. So that might help a little bit as well. Okay? Discrete things can be counted. Continuous things have to be measured. So think about it this way. No, that's not what I meant to say. Here's some examples for you to think about. What if X represented the number of Fortune 500 companies that lost money last year? Would that be a discrete random variable or a continuous random variable? How many Fortune 500 companies lost money last year? That would be discrete, right? Because you have one company, two companies, three companies, four companies, and so on, right? What about the volume of gasoline in a gas tank? That's continuous because we would have to measure it, right? Because we could have 10 gallons, but we could also have 9.99887 gallons and so on, right? You know what I'm saying? You would have to measure that to know. So it could lie anywhere on this number line. It's not just a discrete value. It's not just a whole number value. Yeah, pretty much. Okay. What about the speed of a rocket? That can be measured, so we would call it continuous. What about the number of calves born on a farm in 1 year? That's discrete, right? The silly way to think about it is you can't have half of a calf born, right? You have one calf, yeah, two calves, three calves, and so on, right? Okay, so the fun part about that is that is what we're covering in 4.1. That's it. Okay, there's some other stuff in 4.1, but like I told you earlier, I am following the class that was provided for me since I'm doing this. That's a new thing for me, following the things laid out by the other professor, and this is what she's covered in 4.1, so that's what I'm covering in 4.1. Got it?